Hi, everybody. Welcome back to Dave's Math channel. This is my continuing feature on the Math Lovers book, three-volume series I wrote from 2019 to 2022 that's available on both Kindle and paperback format on Amazon.com. So you can either search for the Math Lovers book or my name, David Taylor, in case you're interested in purchasing. You can purchase any combination of these three volumes. Anyway, that's just a little plug for my book. And as I do every Saturday, I'm featuring another biography of a famous mathematician throughout history. I have 80 of them listed at the back of volume 2, and I'm up to the 33rd of those. And that one is Jean Robert Argand, who lived from 1768 to 1832. He was a French mathematician, and he's mainly known for what's called the Argand diagram. So nowadays it's more commonly called the complex plane. But for any of you guys who studied complex numbers, complex analysis, I'm sure you guys are familiar with this. You can think of a complex number as a vector in two dimensions, where the real components on the x-axis and the imaginary components on the y-axis, as this picture is showing. And the argument argz, so usually use ez for a complex variable, and its argument is just the angle that it makes with the positive x-axis, and its absolute value, which I think is denoted as r in this picture, is just the length of that vector. And anyway, this is a very useful diagram. Um, and that's mainly what he's known for. But he did actually something else that was very important. He wasn't the first person to do this, but he was able to prove the fundamental theorem of algebra, which is a very important result in the theory of polynomials. What it says is that if you have any polynomial, complex valued polynomial, um, uh, you can factor it completely over the complex numbers. In other words, if p of z is a polynomial of degree n, so you can write it as z to the n. Sometimes you can put a coefficient in front of z to the n. This is what's called a monic polynomial, but um, so it's just a n z to the n plus a n minus 1 z to the n minus 1, so on, plus a1 z plus a0. That's a general complex value polynomial of degree n. These coefficients ai can be complex valued, or they could be real valued. It doesn't really matter that much. But it turns out, whatever the values are, that this polynomial can also be written as a product. So you can write a z minus alpha 1, z minus alpha 2, up to z minus alpha n, where these alpha sub I are the roots of a polynomial. They're just the places where the polynomial is 0. And I think you can see if you plug in any of these values of alpha I for z, you will get 0. And they're all the zeros. And the thing that's pretty amazing about this formula is you can always factor it into linear factors. You can't do that over the real numbers, by the way. Over the real numbers, you may have quadratic factors that don't factor over the reals, but they do factor over the complex numbers. The simplest example of that is z squared plus 1. You can't factor that over the reals because square root of 1 doesn't have a real root, but it has two complex roots, as I'm sure you all know, plus or minus I. So over the complex numbers, we can write as z plus I times z minus I. Anyway, that's the fundamental theorem of algebra. It was first proved by Carl Friedrich Gauss, who I'm getting to pretty shortly. A lot of people consider him the greatest mathematician of all time. I think it's sort of a toss-up between Gauss and Euler. But Gauss did some pretty amazing work, including first proof of the fundamental theorem of algebra in 1799. But Argand came up with his own proof in 1814. I believe using the Argand diagram. I think that's an easier way to prove it than whatever method Gauss used. But anyway, that completes my profile of Jean Robert Argand. his biographies. So thank you for watching. Long live math, and I'll see you guys next time. Bye.